Good morning, all of you. In today's session, we are going to start with the 10th standard chemistry and physics. Unit 12, carbon and its compounds, series number 8 is going to be discussed. In the earlier sessions, we gone through what is carbon, what is meant by its tetravalency, what's the electronegativity of the carbon atom, how it will participate in the hybridization, sp3, sp2, sp hybridization, and also allotropy of the carbon, amorphous as well as crystalline forms of allotropes of carbon, including coal, charcoal, coke, diamond, graphite, graphene, nanomaterials, nanotubes, Buckminster fullerene. These topics were discussed. So that is about allotropic forms of the carbon. Now we entered into the versatile nature of the carbon and what is meant by catenation. So catenation property of the carbon is going to be discussed in detail in this session. In addition to all these, we already completed about unit 1 to unit 11, entire detailed explanation available on the channel called World of Competitive Chemistry. Let us enter into our series number 8 of unit 12, carbon and its compounds. Here, we already know that carbon, why we have to study about this carbon. We understand that all the molecules in the life which are made up of which are the forms called hydrocarbons, proteins, nucleic acids, lipids, hormones, and vitamins are composed of carbon, right? So carbohydrates, which are the source of energy, which can be obtained especially from the food grains. So that may be wheat, that may be rice, that may be maize. All these are the major ingredients which are used to give the energy. Those are regarded as carbohydrates. And next is about protein. These proteins also composed of carbon, where these are the sources of amino acids and also having the growth. The property of growth are possible, especially pulses are accompanied by these protein materials. And next is about nucleic acids. Nucleic acids, ribonucleic acid, deoxyribonucleic acids are present, which are the main components of RNA and DNA, which are very essential for the hereditary properties and DNA construction. So here, that kind of genetic matter will be imposed by these nucleic acids. And next is about lipids. Lipids are called fats and fatty acids. They may be oils as well as fats. Both are considered as these lipids. And oily seeds are present. Apart from that, animal fat will be there and cholesterol. All these are the part of these lipids, which are also composed of carbon. And next is about hormones. The glands, pituitary gland, this is a thyroid gland and pancreas. All these are brain. This pituitary gland, which originated in this brain, which is the largest gland in the human body. So all these are able to secrete such a kind of hormones which are essential for the functioning of the body. And next is about vitamins. Vitamins are the micronutrients which are present, which are required in the very minute quantity, but very essential. If the loss of these vitamins are possible, they induce some kind of diseases. So all these materials are very essential for the survival of life, are composed of carbon. And apart from that, so we can synthesize organic materials in the laboratory as well. And the medicines which we are using for the treatment or curative property of various diseases are composed of carbon and its compounds. Even inorganic compounds also present, carbon also present in these medicines. And next is about cotton. So this is a kind of fiber and which is made up of maximum extent of cellulose. This cellulose is the major component which present in the cotton, which is the fibrous material. So it is the fiber material and made up of carbon. Cellulose is the major ingredient. Cellulose is the polymer of glucose, right? And next is about this is called a silk. Silk mainly composed the maximum component of fibroin. Fibroin is a kind of a protein which is secreted by some kind of silkworms. And here these are amino acids which are present in this fibroin and which are the major components of this silk. And any other materials which are also having the carbon as a major component are petroleum oil. This is made up of hydrocarbon. Various kind of hydrocarbons are available, and the quality of petrol is measured in terms of octane number. greater the octane number, greater will be the quality of that petrol. So that purely measured by its efficiency is measured by octane number. So here octane rating is provided for petroleum oil. So based on octane rating, we can identify which is the efficient, which is the high purity petrol. So all these are also composed of such a kind of either cyclic or a branched kind of hydrocarbons made up of carbon again. And even natural gas is the material which also having in relevance to this petroleum as well. Here the less number of carbons will be there in the natural gas. You may go with methane, ethane, propane, till that here natural gas will be there. Gaseous components having less in number of carbon atoms, so here it is also a compound of carbon. So in addition to all these synthetic fabrics, you may see so many kind of even nylon is there, and some other fabrics also present, which are synthesized in the laboratory and having so many kind of applications in the fabrication. So these are also made up of carbon and its related compounds. We are most familiar with the plastic materials which are used as a packaging devices and also such kind of containers where we can store all kind of materials which are of daily importance. And these materials are made up of plastic and composed of carbon. And the synthetic rubber, so here rubber available in two ways, natural rubber and synthetic. So natural rubber extracted from the plant called Brevia Hevia brasiliensis, and that plant able to secrete the latex, which in turn converted into a rubber by blending with the sulfur. And even synthetic rubbers also available like Buna S, Buna N, such kind of materials. So all these are composed of carbon as a major ingredient. So here, why all these materials? So these many materials are possible for the carbon, and what kind of nature it used to impart. So in order to explain that one, we have the property of catenations. Here, catenation is nothing but any element having tendency to bind with its own elements in such a manner, like a chain-like or branched. Otherwise, it may be a cyclic structure. That property is called a catenation. Here, catenation imparted for phosphorus in this manner. Even sulfur also available in this catenation structure. So along with this, carbon is also exhibiting this catenation property, either in the chain-like or branched, otherwise in the cross-linked type of structures. Carbon exhibits a catenation property. So here, catenation property of the carbon is well described in this manner. Either long chain carbon chains are available, and it may exist in the form of branched structures which are available here, and a ring type of structures also imparted for these carbon atoms. Here long chains which are attached by the cross linking, such a kind of cross linked polymers also. So in so many ways carbon able to extend its a chain like structure. So because of such a flexibility, the property catenation, these carbon compounds are available in the huge number in the universe. And this is about carbon has the ability to form the longest chains. So here, as long as carbon chain increases, that will not impart any instability. So here, even long chain hydrocarbons, long chain carbon containing compounds also having a sufficient stability. Millions of carbons are joined in order to make such kind of longer chains. So you may go with the proteins, you may go with any polymeric chains, especially even in the plastics also. Here long chain hydrocarbons are available. So that all these are composed of long chain carbons only. That is purely because of the property called a catenation. And proteins are composed of amino acids. These are the fundamental units. Let us assume all these amino acids are such a simple balls. They can be joined together either in the form of chain, otherwise a branched structure will be there, cross-linking will be there, tertiary structures. Here protein composition can be regarded in three ways. One is primary structure, secondary structure, and tertiary structure. Here, such a kind of peptide linkages are possible. Hence, we can say protein is alternatively designated as a polypeptide chain, because so such kind of amino acids when joining by the peptide bonds. Peptide is nothing but C double bond or NH bonds are called peptide bonds. Such bonds will be repeated in a lot of times. Hence, protein is also regarded as a polypeptide chain. So in that manner, here proteins are the simplest example for the property of catenation exhibited by these carbon atoms. Sulfur, phosphorus also having same kind of nature, catenation properties there for those elements as well. And here, carbon able to form 4 bonds around that because of tetravalent nature. So carbon having tendency to form 4 bonds because it is accompanied by 4 available electrons in order to share with the surrounding atoms. Hence, the simplest example, methane, was provided here with a mutual sharing of electrons, and here central carbon is surrounded with the 4 hydrogen atoms called methane. And carbon also having another tendency in order to make the carbon-carbon double bond test we discussed in the hybridization process, where you can find a sigma bond in between the 2 carbons, and the lateral overlapping above and below of the plane gives rise to carbon-carbon double bond within the compound. And it is composed of C2H4. It is the simplest molecule. Such a kind of long chains also available. Ethene is the simplest example having this double bond nature. And carbon also able to exhibit such a kind of triple bond by the hybridization called sp hybridization. We already studied in the earlier session, where carbon joined together by 1 sigma bond and 2 pi bond formations above and below of the plane. So this is a kind of system. So carbon, not only longer chains, not only branches, not only ring type of structure, there is another kind of property called the multiple bond formation. Either single bond, it is possible. Double bond, it is also possible. Triple bond, it is also exhibited. So here multiple kind of dimensional structures are available. Not only this, here cumulative double bonds, cumulative in the sense double bond, immediately another double bond will be there. Such a property is a peculiar. So when compared to remaining all, here double bond followed by one more double bond, this continuation of double bonds will be exhibited in a kind of system called allene. The molecule will be adjusted itself in order to avoid the strain conditions. How it will be? One of the carbon will be oriented in a vertical manner, in either carbon in the horizontal manner, in order to concise the strains, because both the carbon which is surrounded with the double bond, and these groups are present in the vertical position, they may impart the strain conditions. In order to minimize itself, it used to adjust in order to get the stability. One of the bond is inclined towards the vertical, in either bond is inclined in the horizontal manner. And here that kind of stability, that kind of a molecule is also formed by this carbon. That is a cumulative bond formation. Allene is the simplest example in that regard. So these are the possibilities of the carbon in order to frame various kind of compounds with that. Long chains, branches, cyclic forms, cross-linked forms are possible. And here single bonds, double bonds, and even triple bonds and cumulative bonds are also exhibited by these carbon atoms. So here we can consolidate all the factors into a simple terms, 3 possible terms of why carbon is considered as a versatile material among all. So because of 3 properties. One is the largest number of compounds available. With that, you can find a huge number of a library of compounds with this carbon. So either carbohydrates, proteins, hormones, vitamins, enzymes, all these are made up of carbon and its related compounds. And the largest second is show catenation. Catenation is another peculiar behavior exhibited by the carbon to exhibit a lot of compounds. And there is a possibility to form single bonds, double bonds, and even triple bonded compounds. Various type of bond origination is also possible, and that may be branch, that may be straight chain, that may be cyclic, that may be cross-linked. All these kind of possibilities are available. Because of these properties, here carbon can be considered as a versatile material. So by this, we completed the versatile nature of the carbon, and along with the special emphasis on the catenation property of the carbon atom. So in this session, we discussed exclusively regarding what is meant by catenation property of the carbon, and in what way it able to exhibit single bonds, double bonds, and triple bonds, straight chains, branched and cross-linked polymers, and the ring type of structures are possible, and what is the main cause for the versatility of the carbon atom. Hope this session will helpful for your preparation. Thank you very much for your consistent listening. Thank you one and all.